All right, so we're looking at 7.4 today. Last class we did 7.3, 7.5, so we're doubling back and hitting 7.4. After this section, we'll be done with chapter 7's content. So we're looking at 7.4, properties of triangles. Similar triangles will be similar objects that have the same shape, but not necessarily the same size. All right, so we're looking at similar triangles. And also, I've already written this stuff out, so just throwing this back out here. Don't forget that if I scroll up before you're ready, always feel free to unmute. Say, hey, can you hold for a second, or can you scroll back down, or whatever the case may be, so I can make sure that you're able to write this stuff. Can't see most of you, so I don't know if you're done writing or not. So it's all good. Just let me know. So once again, similar triangles, similar objects that have the same shape, but not necessarily the same size. All right, so properties of our similar triangles. The ratio of corresponding sides are going to be equal. The ratio of corresponding heights is equal to the ratio of corresponding sides. And some of this stuff makes more sense once we put numbers on it. All right. The measure of corresponding angles are equal. All right. Try to wait for you guys to copy. All right. So hopefully everybody ready. So here's just an example of two similar triangles. And you see that we have AB on the smaller side corresponds to DE on the larger. When I say I meant smaller side, on the smaller triangle corresponds to DE on the larger triangle. So we're talking about this bottom down here. So AB over DE is going to simplify to 1/3. And then when you look at BC over here and EF, they correspond to each other. And that'll be 3/9, which will give us 1/3. And then AC and DF corresponds to each other, which also gives us 1/3 again. That's 4/12. So this is what they mean by the ratio of corresponding sides will be equal.
Excuse me,
Mhm.
Professor. How
Yes.
did you get the numbers from those like the
Oh, that was
one?
just given. In this diagram, it's just given. Yeah. Yeah, don't even worry about that. I was just showing you an example of two triangles that are similar.
Okay,
And so, and just trying to put numbers on what this means to have corresponding sides and stuff.
Okay.
So that's all. Yep, yep. So in an example, you'll see when we get there, this might be X or something like that. Then we have to use these relationships in order to find X, you know. But
Okay.
like I said, this was just an example to show you what we meant by those ratios being corresponding and all that good stuff. So
Okay.
yeah.
I have a question.
Yep.
So with this lesson, are we gonna be learning like cos and sine and like tan and stuff like that?
Nah, we're not gonna get into trig. No,
Okay.
no, no, you'll be all right. All right. But this is like, that you're right though. This is that stuff that can lead to it. But yeah, we're not going that deep. All right. So here we have triangles ABC and DEF. They are similar. It tells us that they are similar. And then it tells us to find FG. So no, so what they did was they had it set up this way, wherein they gave us the height of the smaller triangle, which is CH, that's 4. The base of the smaller triangle, AB, is 8. Then they gave us the base of the larger triangle, which is 12. And they told us to find FG, which is the height of the larger triangle. So we can call that X, since that's what we're trying to find. Now, when setting up your proportions, you have to make a decision on how you want to set them up. So notice the way I set mine up is I put the small dimensions over the big dimensions, or you could do big over small. It doesn't matter as long as you're consistent throughout your proportion. In other words, I have my smaller side on top, AB, and then here CH is my other smaller side. And then the side that corresponds to AB is DE. So that's on the bottom of AB, but that's the larger. And then here, FG is the missing side, but that corresponds to, the CH. Questions on how I set up my proportion?
No.
All right. Thank you. Thank you. So now I go ahead and substitute the numbers or the expressions that represent each side. So AB is 8 over DE, which is 12. CH is 4. And then our unknown, the piece that we want to find out, FG is X. Now, if you want to solve, cross multiplication is always an option. You always take your denominators up to the opposite numerator. Create that X. And that'll be 8 times X on the left, 12 times 4 on the right. And from there, we can divide by 8. And 48 divided by 8 is 6. That'll be our solution. Our missing side. All right. Hey, everybody good before we scroll up to the next one? All right. So here, just another way to establish that you have similar triangles. If the 3 angles in one triangle are equal in measure to the 3 angles of another triangle, then the triangles are similar. All right. Next one, if two angles of one triangle are equal in measure to two angles of another triangle, then the triangles are similar. Because don't forget, all of the angles in a triangle are equal to, when you add them together, are equal to 180. So if you know two of them, then you know the third one because you can just subtract those from 180. And if they're equal, if two of them are equal to two of another triangle, that means they're going to have all three angles being equal. So that's why I says if two of them are equal, then you know the third one is going to be equal as well. And so that's what that little diagram states. The one slash says that those two top angles are equal. Double slash says that the two on the right are equal. So if we know two of the angles are equal, that means the third angle has to be equal as well. And if all three angles are equal, then that means we have similar triangles. And in the red, that's just reiterating what I said, that the sum of the angles should be an S there. Sum of the angles in a triangle is 180. All right. All right, so in the figure, and let me erase some of this stuff because, so in the figure, angle B and angle D are right, oh, let me do that, right angles. Let me see what's going on here. Make sure I didn't erase something I want to keep. All right. Trying to keep this stuff that I need. All right, there we go. So in the figure, angle B and angle D are right angles. AB, that's side AB, is equal to 12 meters. Side DC is equal to 4 meters. And side AC is equal to 18 meters. Find the length of CO. All right. Give you a chance to. And this is the diagram right here without any of my drawings on top of it because I wanted you to see the way it looks first. All right. So looking at our triangles, we have a smaller triangle up here, bigger triangle down here. And we need to establish if they're similar or not. Well, we know that one angle in each is a right angle, according to the definition. They told us that. And then don't forget we have vertical angles right here. So that's a relationship they expect you to remember. And that means that both of those angles are equal. So if both of those angles are equal, and we have two right angles, that means they're equal. That means that this third angle is also going to be equal. So this means that we have a similar triangle. So remember, if we didn't have a similar triangle, then we wouldn't be able to set up our proportion. So we need to know that they have similar triangles. Right. So now we need to set up our proportion. And I'm going to do small over big, just like I did before. So the side of 4 corresponds to the side. Wow, I messed up. Come back over. Let me see if I can get my stuff to go back over. Man, come on. All right. So that bottom side corresponds to that top. You know, that's the side that's connected to your right angle and that double slash. So the 4 and 12 corresponds to each other. So now I want to find CO. And CO is this side right here. So the side that corresponds to CO is AO. All right. Now they don't give us either one of those, but they give us AC, the whole segment. Talking about going from A to C, that whole segment. So they give us that total. Whenever they give us a total, but they don't give us any relationship between the two pieces, we can let one be X. So I'm going to call COX. And then I'm going to let AO be equal to 18 minus X. So whenever they give you the total, you can always let one be X and then the other one be 18 minus X. And it doesn't matter which one you call which, because once you do your calculations, it'll all come out to give you the same numbers. But you'll let one be X and the other one be 18 minus X, or the total minus X. And then you'll be able to set up your proportion, X over 18 minus X. So before we go any further, questions on the setup? Questions on anything that I said? All right, any questions before we go to solve? Cross multiply. So that will set us up 14 times 18 minus X equal to 12. I said 14, 4 times 18 minus X. And that's equal to 12 times X. And then distribute the 4. And that'll be 72 minus 4x equal to 12x. Solving for x will cause me to add 4x to both sides so that 4x can cancel on the left. Then on the right, I have 72 equal to 16x. Divide by 16. And x is equal to 4.5. Any questions?
No.
All right, thank you, thank you.
Yes, I have a question.
Mm-hmm.
Which you at the top, the 4 in the parentheses, 18 minus X. You multiply 18 times 12. That's how you got 172.
Now, you talking about right here?
Yes, and then you got the answer 172.
I see. You talking 72?
Oh,
Or...
I did like a 1. I'm
Oh
sorry.
no, my 7 was just a little deformed.
Okay.
Yeah, it's just 72.
So you multiply
The 4 times 18
4 times 18. Okay.
and then 4 times the x. Yep.
So what does the x represent?
That's the unknown. X is going to be CO.
Okay.
Yeah. And that's what we were looking for. We wanted to find the length of CO. So we called that X.
Thank you.
Not a problem. All right. So let's look at congruent triangles. See something on my screen. Okay. All right. So congruent triangles, they have the same shape and same size. So we have 3 theorems that we will be using in order to establish if we have congruent triangles or not. So the first one is side, side, side. Side, side, side theorem. If the sides of one triangle are equal to the corresponding sides of another, then the 2 triangles are congruent. All right. Side angle side theorem. If the 2 sides and the included angle of one triangle are equal to that of a second triangle, the 2 triangles are congruent. And here we just have a little diagram just talking about what we actually mean there. 2 sides and then include an angle. So 2 sides and then the angle that's in between them. So we had side, side, side. Now we're looking at side, angle, side. And then the last one's going to be angle, side, angle. So if 2 angles and the included side of one triangle are equal to that of another, the 2 triangles, excuse me, are congruent. So once again, here we have a generic diagram of what it means. So 2 angles and then the side in between those 2 angles.
Can you go back up a little bit?
I don't know where to stop.
You can stop. All right, can I scroll up? Are we good?
see what's X. Okay. All right, so next exercise, they're asking us, are the triangles congruent? And we're going to use the last, the three theorems that we just finished talking about. We either have to have side, 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 or angle, side, angle in order to prove that. If we cannot lean on either one of those theorems, then we cannot establish that it is or is not congruent. So looking at this first one right here, are the triangles congruent? Hold on, let's see some. Okay. So we see that in both cases, we have the same measurements on our angles. We have angles of 80 degrees, 45 degrees, and 55 degrees. So we have angle, angle, angle. We have our two triangles that have the same angles that are equal to each other, but that was not one of our theorems, either side, 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 or angle, side, angle. So these triangles are not necessarily congruent because they do not satisfy either one of the theorems. All right. All right. Next one, notice we have sides of 18 that are equal, sides of 16 that are equal, and then in between both of those is the 60 degrees. So we're looking at side, angle, side. And so these are congruent, once again, because of side, angle, side. All right, questions on those two? All right, so next we're looking at the Pythagorean Theorem. All right, so it's only used for right triangles. And the formula is a squared plus b squared equal to c squared, wherein a and b are interchangeable. So also they're looked at as being, sometimes they're called legs. C is your hypotenuse. And so you can also write this as leg squared plus leg squared equal to hypotenuse squared. All right, somebody said something in the chat. Somebody said, no, sir, was that to me? All right, so only used for right triangles. C is always the hypotenuse. C is always the longest side and opposite 90 degrees. So you know that 90-degree angle is here. And so it's always opposite 90-degree angle. C is always on the side of the equation alone. So C is always over there by itself. And I already mentioned before, A and B are interchangeable. All right, scrolling up. All right, so they want us to find the missing side. Where, oh, I lost my pen. Wherein they would have something like this diagram like this. One side has 5 centimeters, the other side has 12 centimeters, and then have a missing side. And since this is opposite the 90-degree angle, that means that side is C. That's your hypotenuse. So you plug them in accordingly. Once again, A and B are interchangeable. Doesn't matter which one of those they are, but C has to be on one side by itself. All right, 25 squared, well, 5 is 25. 5 squared is 25. 12 squared is 144, equal to C squared. So now we want to solve for C. In order to do that, we'll take the square root of both sides. Square root of 169 is 13. And that'll be the answer. So these will be some form of that when you have 2 other sides and you have to find the missing one. I think that's it for this section. Questions?
No.
Anybody have any questions out of chapter 7? Maybe you have some questions right now. That's it for 7.4. And actually, that's it for chapter 7 altogether. All right. Thank you. So that's it for chapter 7 altogether. So, like I said, on next class, we will be looking to review. I'm not going to cover any new material. Depending on what questions I ask, I may or may not do the recording. I mean, no one really asking anything. There's nothing to record, right? So, you know, if you only get one recording this week, it's because, you know, no one really had any questions. But, you know, we'll see. Outside of that, that's all I got today. Anybody got anything before we dismiss? Anybody?
Yeah.
All right. So once again, check this stuff out. Excuse me. Thank you. Check this stuff out. See if you have any questions. Make sure you bring them all next class. And I will see you on next class. Y'all have a good one. Be safe and take care.
You too.
Thank you. You too.
You
Thank
too,
you,
man.
too.
Thank you.
Thank you.
You too.
Appreciate it. Is somebody still copying? I think I saw somebody was still copying. Or are we good? Nope, look like she good. Okay. All right. Everyone take care.